Alcohol is made from things that have sugar or starch in them, like corn, grains, or other kinds of fruit. No matter what we start with, we're going to cook it down into a sauce. We're going to condition this mash so that we'll be able to ferment it. First, we have to cook it down into a thick sauce, and then we'll correct the pH by dipping this paper in and seeing what color it turns. Depending on the color that it turns, we'll know what the pH reading is. As the corn becomes thick, we'll have to thin it out with enzymes. Now, enzymes are items that come from bacteria or seeds which break starch down into sugar. As the enzymes are mixed in with the corn, they'll break it down very rapidly and thin the corn right out. This will happen hundreds of thousands of times faster than it would in nature. In fact, it gets so thin that it won't even stick to the spoon. Now, we'll often have to correct the pH with lime or acid at different parts of the process to give us the correct conditions for fermentation. Adding acid has to be done carefully, as you can see the reaction, which is quite violent. With the acid added, we'll now be able to check for starch. We'll use household iodine, and as you can see, the starch turns quite purple when we add iodine. This tells us the batch isn't quite done yet. Now, all the stuff we use for making alcohol can be found around the house or at chemical supply. This here is baker's or distiller's yeast, yeast that will go ahead and eat the sugar that is now in the mixture and make it into alcohol. As the yeast are added, they'll first begin to reproduce, as you're seeing right here. As they begin to get much more vigorous in their reproduction, you'll see some quite violent reactions as they begin to produce the gas which makes them float. Now, as the yeast reproduce, over the next 2 or 3 days, they will be producing alcohol until they reach about 10 or 12% alcohol, at which time they will be dead drunk and they will have finished the process. Now, as the yeast heat up the sugar, they also breathe out carbon dioxide, as you can see them bubbling away right here. As long as the yeast are breathing, we know they're alive, and when they stop breathing, the process is over with. The amount of time it takes will vary on the material. Things like grains take a long time. Once it's over, they begin boiling the mixture, and the alcohol vapors that begin to rise through this column. Now, this is a small column, a tabletop model, but as the vapors rise, they will get stronger and stronger in alcohol until they reach quite close to the top, which you're seeing here. This coil cools the vapors to a particular temperature, and depending on the temperature, we can pick any proof we want. The vapors leave this part of the column and enter the condenser. And this is the final phase of the process, where the alcohol is now made into a liquid. Now, the blue liquid here is cold water. The alcohol will be condensing on the outside of the coils in just a few moments. Stills like this are very energy efficient. They're able to produce about a gallon of alcohol using about 1/3 of a gallon's worth of energy. So we're seeing technology that is sophisticated but simple enough for people to use. The clear liquid dripping off is now the alcohol. Now, if we boost up the cooling water a little bit, we'll see quite a bit more of it. And a still like this will only produce a half a gallon per hour. More modern stills, ones you'd see in your backyard, would produce more like 80 to 100 gallons in a day, which is the basic size we recommend in our workshops. The alcohol does collect at quite a rapid rate, and in about a half an hour of running time, we'll collect enough drips like this to fill up a quart-sized flask. As you can see, the alcohol is quite clear and looks just like water, but there are impurities in it which make it undrinkable. Things like esters and ketones and aldehydes. They all look clear, but they would give you a hangover you'd never forget, or one you may never wake up from. This alcohol is quite strong. In fact, it's well more than necessary to run a car. As you can see from our hydrometer, it's over 190 proof. We only need 160 to 190 proof to run a car. Now, the flame you're seeing, a very faint flame, is alcohol burning. And it's a very clean flame and a very cool burning flame. It's very safe, actually. This is gasoline, which is quite a vigorous flame and quite a dirty one. And what we're going to be seeing is what this does to your engine and also the safety of alcohol. As you can see, alcohol can be put out with water, where gasoline, of course, is only spread by water. Now, as the gasoline burns out, you can see how black the cup has become. That's similar to what happens to the inside of your engine while running on gasoline. As you can see, the alcohol cup is still completely clean. Now, as we use alcohol in vehicles, we start to find very long engine life and very quiet and cool running. In fact, alcohol turns out to be the ideal fuel for internal combustion vehicles. Although we lose a little mileage, about 10 to 12%, the rest of its effects really make up for that small deficit. As you can see, alcohol burns very cool, and I can put my hand on what usually would be a 500-degree exhaust pipe. And running on alcohol is quite good in motorcycles, as the vibration level is quite reduced. In fact, We've even seen Harleys converted to alcohol that were almost civilized. This small bike here even benefits from alcohol's vibration-free running. This is my still here, and as you can see, it has nothing to do with the old vision of a copper coil kettle type moonshine still. In fact, the technology in this still is, let's say, borrowed, not quite stolen, from oil company technology. This still here will produce about 8 to 10 gallons of alcohol per hour, or about 100 gallons in a day. We use pressure and temperature gauges to be able to determine the proof at any time in the process, and we can test the purity right here in the hydrometer. Now, alcohol stills like this are generally fired by wood, and here's the firebox, for instance, on this one. They're also used with natural gas, etc.